Hello thinkers, let's talk a little bit about truth tables and how you do them on the Power of Logic website. I've zoomed in here so where all you can see of this particular web page is the truth table that we're going to be working on. I've done that so that it's most visible to you on your computer screen. But hopefully this looks familiar from getting on the website if you could see the rest of it. For instance, it says this up in one corner, this in the far corner, etc. Okay, with regard to truth tables, you should be able to, from reading the textbook, you should be able to construct a truth table on your own. And if you see what we've done here, is the argument has been symbolized such that the capital letters are standing in place of atomic statements. And we've got various logical operators working here to capture the logical meaning of the argument that we're evaluating. Over here we've listed all of the atomic statements. We've only got 2 in this one. And then beneath we've exhausted the combinations of truth value assignments. So for instance, they could both be true, one could be true, the other false, and you can see the rest. So the first task here is to fill out the truth table. Now when you're doing these by hand, there's various things you can do that are handy. All we're really concerned with is the truth value of the premise as a whole, which means when we get down to checking the truth value at the point of the main operator, that's going to be our primary concern. So let me go ahead and fill this out as it should be. So see what I've done with each of these. I've taken in this row A is true and B is true, so this whole disjunction would be true. The negation of A, since A is true, would be false, and B is true. So we're just filling in the assignments and then working off of the logical operators and putting the truth value directly underneath those. On the website, if you type in these instances the truth value assignment under the letter, it's going to tell you that it's got too many assignments. There are other sections of this website that require you to put a truth value assignment under the letters as well as the operators, so pay attention to that. That might be something that you run across. And if you're ever in doubt, go over here to the left side where it says help, and the help on each page is associated with the assignments for that page. So hopefully that's helpful. Alright, so let's check the truth table now. I should have noted too that the letters are supposed to be all capital. If you assign a lowercase letter, I don't think the website particularly likes it. At any rate, so we've done a good job here assigning the truth values of the premises and the conclusion. Now the question when we're evaluating the argument is whether or not it's valid. And in this instance, here's what we need to be asking ourselves. Is it the case that when all the premises are true, the conclusion is also true? Because if you remember that by definition, validity is when the premises are true, the conclusion is guaranteed to be true. The great thing about a truth table is that we've exhausted all of the possibilities. So what we can do is consider every possible circumstance and see if it's the case that every time all the premises are true, the conclusion is also true. This one's easy enough because there's only 4 possible scenarios to consider. Alright, so let's look at the first one. Are all of the premises true? No. So really this row doesn't matter because, again, for an argument to be valid, it has to be the case that when all the premises are true, the conclusion is guaranteed to be true. If the premises of the argument aren't true, then the argument's already bad. So let's look into the second row. Are all the premises true? No. We've only got one instance in this argument where all the premises are true, and it's the third row. Now let's look at the conclusion. Notice that it's also true. So what we discover as we look at this truth table is that this argument form is such that every time the premises are all true, the conclusion is also true, which means that the argument is valid. Now what the website wants you to do is, if the argument is invalid, you want to check the row that would demonstrate that it's invalid. In this case, we don't have any rows that would demonstrate the invalidity. What that would look like is an instance where all the premises are true and yet the conclusion is false. But since we don't have any rows to check, we're just going to answer that this argument is valid and bask in the praise that is the Power of Logic website. Of course they get much more complex from here, but it's basically the same task on every single one. As usual, if you have questions, please post them on the blog and I'll get to them as soon as I can.